Okay, so Assalamu alaikum. Today we have our new class on microprocessor interface, and today we're going to start the lab. Okay. Mm, okay, so okay, so this is the very important link that we can start from there, and this is a circuit basics official software, official website where you can understand how this 7/7 display actually work, how to interact with Arduino, and how you can get some interactive uh, value or interactive display that you want to figure out with the help of the Arduino and the 7/7 display. Okay, so as far you know that the 7/7 display is something that has 7 pins, 7 LED. It's not the 7 pins, 7 LED. Every significant LED considered to what considered to a diode, and each diodes or each bulb or each mm, whatever you can say, the LEDs will require some voltage because some currents, and that must need to be optimized. And for that reason, and there is some proper monetization as well, because you don't want all the LEDs turn on and turn off at the same time. Maybe it fluctuates, it varies according to your demand, whether you want to show some output like 3, 4, 5 with the help of those displays. Okay, so in a single view or a top view or side view, you can say that that's a single display, and there are some pins over there. Okay. So if you look very deeply, you can watch over there. So it's a basic LED where it has an anode part and a cathode part. So this anode part is a positive. You can say the longest part or the longest legs of an LED is the anode part, and the shortest leg or the shorter one regarding that longer part. So that shorter part will be the cathode. Okay, fine. So there's some emitting options or some arrows that has some indication towards the uh, top level. So uh, maybe it shows that yes, something is emitting from here. Is exactly that is right, because this sign is very much familiar and very much you can say um, useful for the LED, because this LED considered to a light emitting diode. So the light emits from the diode. So you can say that is light emitting diode. And this emits actually the ray where you can see LED will turn on. With the help of this ray, you can see that LED will be turned on. And for that particular turned on and turned off, you have set some particular voltage. Okay, so that's the reason right now. And you can say if you connect a LED over there, and there must be, you need to explain about these things like this. Okay. Okay. So how it works actually. See, the anode part is connected to the resistance because you want to resist some voltage that has been coming from the Arduino, because the Arduino is already has been powered already. Okay. So note, all it is need a current limiting resistor because placed on their either the anode side or the cathode side to prevent the LED from the burning out. Okay. And the resistor value will determine how bright the LED will shine. And like as you can say, 1 kilo ohm is a very good place to start, but you can calculate the height of the value with the LED resistors calculator. So how this LED resistor calculator works is a basic phenomenon that you have learned with the Ohm's law. V is equal to I times R. So you have to set the value of R according to the demand or the consuming power of voltage and current. Basically, on the power of LED that is considered to the voltage and current. So you need to focus on the voltage and current. And with that voltage and current, you have to set the particular ohms. Then you can say your resistance will be set like this, and you can find the value of the particular resistance. Okay, fine. Now you can see that that LED has been connected with the resistance and the Arduino is over there. So this is the basic code, and probably I think you are very much familiar with this code. How? Because if there is a single LED, a single time operation, single time work, if it does not contain any repetition of work, then you don't need to go for the loop. So it's a closed loop with zero condition, zero value. So if there's a work that has been considered to a once time for a single view, then it's something you have to declare the pin mode over there. And the task, what he should do at the time is just to digital write 7 high, means you will have to make higher to the pin number digital 7. So digital 7 is the pin, digital pin of Arduino, and you were setting the value high, means you are setting the value to the 1, and the 0 means that is low. Okay, so cathode to GPIO, the cathode to GPIO, that's the starting of the 7/7 display. That's how it works actually, and you have to know details about it. Okay, so digital, to turn on the LED, the digital pin is switched low, which completes the circuit to ground. And in this case, we drive GPIO pin 7 low with digital write 7 low. This closes the circuit, always current flow from VCC to ground. That means whenever you are setting the value low, it seems that you are just closing the circuit at the time. Okay, you don't want to to flow the current from this to ground. That means the circuit will be off. So on, the LED will be off. Okay. Now let's come to the main section, 7/7 display. We have already talked about this 7/7 display, and that is very much important actually. Just to know that very much important part is the LED. If you don't know about the LED, if you don't know about the anode and cathode, if you don't know the portion and how it is going to work with this component. So if you want to watch the skeleton of the LED, then you'll find a anode. So let's jump very much slowly. So this is the classroom. If you want to break the classroom, before breaking the classroom, you will find it's a building. And inside of the building, there are lots of classroom, lots of floors. So inside of the floors, there are some whatever it is, a classroom, and every classroom can be divided with a lab or theory classroom. And if you want to go very much deep inside of it, then you will find that the cell is the main important thing that has been made with brick. So ultimately, these classrooms are made with brick. And in addition, there can be iron, ores, and so on. Okay. So if you look at this 8 value, you basically find a display like this. So in general, you will find a 7/7 display. And if you look deeply or go inside of the 7/7 display, you will find 7 LEDs. And basically 8 LEDs. In general, you'll find 7 LEDs. Inside of the LEDs, what contains there? There's some what? LED bulb, then you will find diode. And inside of the diode, what you will get? There's some materials. Okay, the basic formation of diode, PN junction, NP junction. Okay, so that's the main important thing. So right now we're at the stage 2, where we can find the LEDs actually. Okay. Okay, fine. So right now we can just to do the basic text 1, 2, 3, 4, 4, 5, 6, 7. So there are 7 LEDs and DP means dot. Okay, this dot pin is very much important just because of if you want to show some dot like degree Celsius, Fahrenheit, or something like that, 73.6. So the point will be like this DP. Okay, so we have already discussed these things, these criterias and examples in the theory section. Now I will show you that how it works and what's the code behind this. Okay, so there are two types of displays. One is the common cathode, and other is the common anode. Okay, so common cathode is something. Let's see. The cathode is like this, the plus portion, and the anode is the minus. So if the cathode is plus, then what should I do actually? Cathode minus, sorry, cathode minus, anode plus, cathode minus. Maybe there's a mistake actually. See? Yep, there's a mistake. Anode means plus, the shortest leg. Okay, so if anode is plus, then why they differ it like plus like this way? So dot portion is indicates to the cathode. Yeah, it's okay. It's okay. Common cathode. So this is the cathode portion. So there will be minus, anode means plus. So all the plus are individual, whereas this portion is something like this. Yes. So if I divide these two wires, okay, I divide this wire and cut it over there. So if I wrap up and make a small package and tied up with very strongly with the copper and solder it, then it will be work as before. Okay, it means I have shorted the lines. And another, if I want to bring wire outside from them and connect it to that particular open spaces, then I can get another line that is shorted. So every single line, this line, this line, this line, this line, this line, every single line has been connected and shorted over there. And I can get a minus portion to the common cathode side. So this common cathode side is the safest part and most easiest, I mean, most user-friendly part that people want to deal with it because it's very much easy to use. And yes, and I love it actually just because of its user friendliness, its availability, and yeah, and these are the sort of things actually. Okay. So in common anode display, you can see that all the pluses has been common portion because there will be one plus and the ground are individually minus. So there will be an individual 7 grounds to the common anode, and there will be individual 7 positive side to the common cathode. So whenever you are getting individually positive sides in number of 7, so you have to connect 7 positive portion on that, and you know the resistance is obviously connected with the positive part of the diode. Okay, so common cathode display is the most user friendly. And now kinetic submission display to the Arduino is something like single digit bit segment displays typically have 10 pins. And these 2 pins come to the ground and the other 8 pins is connected to segments and every each diagram of the popular. Okay. Now you have to understand how to tell if you have a common anode or common cathode display, because whenever you're getting a display to your hand, you have to find whether this display is a common anode or common cathode. So that's the practical stuff. Okay. So this is software freezing, and you can say that like this. To determine if a display is common anode or common cathode, you probe the pins to the test circuit. So there will be test circuit over there and common ground, black, and so on. There will be plus minus. So if two different pins lights up, okay, connect the ground wire to any pin of the display and insert the positive wire into the each of the other pins. If no segment lights up, move the ground to the wire to the another pin and repeat the process. Do this until at least one segment lights up. It means every single pin you have to connect the plus with it, and to the ground you have to connect the black wire with the display. And when the first segment lights up, leave the ground wire where it is and connect the positive wire to each of the other pins. If a different segment lights up with the different pins, you have a common cathode display. So first of all, I will take a 7/7 display. I will connect the display with some sorts of things like this is my pin number. It's a ground pin. Okay, I'm going to connect the ground with the ground, and the other pins. Okay, fine. I'm going to connect the anode with the plus. But if it's not working, then I have to decide that okay, I have to check with the other pins. So somehow, if I get the output from there, then I have to think about that. Okay, let's try with the different pins, and if it works consequently as before or as the procedure you have started, so then you can understand, okay, fine, it's common cathode. If the LED will not turn on, then you have to understand, and then you have to check repeatedly, consequently with the other pins. If it does not make any sense or does not pop up or blink or any kind of notification or light over there, so you have to understand, okay, fine, that is not the common cathode, that will be the common anode. Because I don't need to connect the ground over there. I will get different grounds, I mean different minus in common anode. Okay, but the plus will be the same. So to check with the value of the 7/7 display, otherwise you can't describe. In formally, normally, officially, you will get 7/7 display, the cathode one, not the anode one. Okay. So, there are some libraries that has been available in the internet, and just to just to ensure you about this library, because whenever you're going to work with it, you have to think and you have to make some such of things that yes, this library is going to control the other display, because you can't work unless you set up the zip file, you set up the library to the particular portion. Okay, this library is something like make your task easier, and there's some lots of other purposes as well. Okay, printing numbers to display. I have assigned you a task to understand the function, string, and array. Did you? You didn't. So how can I say that you are going to understand these things? Okay. So, I mean, without the wire connection, without the proper connection and the proper display, and what? You understand, obviously. You have to understand. Without what? The knowledge of coding, array, function, and what? Array, function, string. So these three streams are most important for any kind of coder for a triple engineer. Okay. So this is the most important thing, and you have to work on that. Okay. So did you read it about that? And do you have any idea what is class, string, function, array? So you don't have any idea. Fine. Okay. So let's get some idea on that. And if you don't study on that, then it will be ultimately your fault and your loss. It's not mine. Okay. So the course has been given over there, and in the next class, we'll definitely connect with the 7-segment display with the with all the resistance and the proper jumper with Arduino. Then we'll definitely find how this system works. Okay, so we'll see the two setups. One is through the simulation, and the other is with the code to the practical hardware setup. Okay, and we'll definitely focus on it. Okay, so that's it for today, and I will obviously wait for your call to get the ultimate output with the 7-segment display and the Arduino, and that's it. Cheers. Okay. Assalamu alaikum.